Okay, the moment we've all been waiting for. Exciting stuff today. Geometric dimensioning and tolerancing, often referred to as GD&T. This drawing should look familiar from the previous video, and you will remember that there were some things here and here and here, as well as these guys here, here, and here, that we told you to ignore, as well as something down here. And that was because we hadn't covered GD&T yet, but we are covering it now as promised. So, what is our goal today? Our goal is to give you a brief overview of GD&T, so you'll be exposed to it. So when you see these symbols, you will at least have some idea what they are, general idea of how they work, and know where to go to find more information about the details regarding the proper way to interpret the application of the geometric dimensioning and tolerancing symbols you will find on the drawing. I know that was a mouthful. The first thing I'm going to tell you is that the Bible for GD&T is something called ANSI, which is the American National Standards Institute, Y14.5. That's the standard. There's a 1982 edition, and if you see older drawings, you'll need to reference that. And then there is a 1994 edition that is the most widely used right now. There is a later amendment to that, but we don't need to get into that right now. So if you see this stuff on the drawing, until you become an expert, and even thereafter, this is where you'll want to go to clarify any interpretation issues. You can also Google this stuff, and there's a lot of information out there. So let's get started. What are the symbols? Well, these symbols, each of them represents a type of tolerance. And GD&T came about because, I'm going to color code these, there were engineers trying to describe complex tolerance schemes on drawings, things that weren't as simple as our 4-inch block with a plus or minus 30 thousandths of an inch tolerance on it that we had in our last instructional videos. So today we're just going to try to get an overview of what the symbology means, and a couple of real quick examples of how it's applied, just to give you a taste of it. Future videos will go into great detail on this stuff. So the first symbol that you might encounter is something we call straightness. As the name implies, it is a tolerance of how straight something needs to be. The next one is flatness. The next one is circularity, or sometimes called roundness. Then we have cylindericity. The next group of tolerance symbols contains two, and the first one is what we call a profile of a line and a profile of a surface. And the next group contains three symbols. The first is angularity. The next is perpendicularity. And the last one is parallelism. The next group also contains three symbols, And the first is called true position. The next one is concentricity. And the last of those is called symmetry. And the last group has two symbols, and the first is circular runout, and the last one is total runout. Oops. Now, these two, we call this family of tolerances of runout. Seems obvious enough. These three are tolerances of location. These three are tolerances of orientation. These two are tolerances of profile. And the first four are what we call tolerances of form. Now, the application of these varies in the way that they are communicated on the drawing or implemented on the drawing. It varies depending on the type of tolerance. And as I said, we could do an entire video on each of these and probably two on true position, but we're not going to do that. We're doing one video and we are trying to give you an introduction or an overview. So we're going to take a quick look at the three types of tolerances that are types of GD&T that we encountered on this drawing. Okay, and by going through those quickly, you should get at least a taste of how this stuff is implemented, and it'll give you something to think about if you're seeing drawings back at work or in school. Okay, the first thing I'm going to mention is that you're going to encounter two types of frames, what we call frames, and we're going to go for blue here. The first is what we call a feature control frame. Right? And I'm going to show you down here where they are. I'm just going to abbreviate it, but this is a feature control frame. Right? This is a feature control frame. And this is a feature control frame. All right? Now, a feature control frame in its simplest form is a rectangular frame, and it gets a symbol here and a tolerance here. Right? One of these symbols and then a tolerance value. Now, they can be more complex than this, but in its simplest form, that's what they look like. Then we have another type of frame, and that's going to be the green ones. See the A, B, and C, right? These are what we call datums, or datum frames. Right? There's three of them on this print. So a datum frame right, which in the most recent standard they will look like this. A little triangle attached to the surface or the feature that they apply to, and then there'll be a letter in here, right? And that indicates that it's a datum. Now I'm just going to let you know, even though we're not going into too much detail, that in the 1982 standard, right, that was the that datum frame was from the 1994 standard. In the 1982 standard, you'll see a datum frame will look like this. It'll be a rectangular box, and it'll still have a letter in it, and it'll have a dash on each side of it, and it won't have this little triangle tail. And then it'll have an arrow pointing to the feature, or a leader line or an extension line, and that's the 1982 standard. So if you see drawings that have this, you'll know they're older drawings. It's still implemented the same way. If you see drawings like this, you'll know they're the newer standard. And usually somewhere, if it's a good drawing on the title block, it'll say which year the standard applies. Obviously, you can look at the date the drawing was issued, and that'll tell you. So you have feature control frames and tolerance or datum frames. So what you'll see here, we'll take the easy one first. This is flatness, the symbol for flatness. What does that mean? It looks, I'm going to redraw it up here, but here's the symbol for flatness, right? It's a tolerance of form. So you have a feature control frame. Looks like this. It's got a symbol in here for flatness, and it has a number here. It was 0.5 thousandths of an inch. We read that as that surface that the feature control frame was hung on has to be flat within 0.0005 or 0.5 thousandths of an inch. Okay, so that's saying that bottom surface of this plate has to be flat within 0.5 thousandths of an inch. The next one is parallelism. It's right here, and this one I could tell you is missing. It should have another box here. I'll explain it up above, but this is parallelism, and that's hung on the top surface. Right? There's an extension line here hanging this feature control frame on the top surface. So if we go up here and we draw that one, what this one says is it's parallel within 0.001 to datum A. That's how that would read. Parallel to datum A within 0.001. And the last one down here is true position, okay, and that's relating to this hole. It's hung on the diameter call out, the diameter dimension of the hole, and that has a feature control frame. It's actually bigger, and it had the true position symbol, right, that we saw up here. It was true position, and it had a little diameter symbol. When we apply true position to a hole, we are defining a circular tolerance zone, and that's what the diameter symbol means. And it said 0.005. It had A, B, and C. That, the way we would read that is true position within 0.005 or 5 thousandths diameter to datum A, B, and C. Again, in future videos we are going to go into detail about what exactly all of this means, but at least if you see this on a drawing, you will know how to read it. And based on what I've just told you, you should know how to read the rest of these. Concentricity to A within 0.005. Perpendicular to B within 0.010, etc. Okay? In the advanced GD&T videos, we are going to drill down into great detail on all of these. I told you this was going to be exciting.